Hello and welcome to Science Visualized. Today we're going to be looking at orbitals. Now in order to do that, we're going to start with wave equations. What are wave equations? A wave equation is an equation that describes all the behavior of the electrons in an atom. Number two, we're going to look at a wave function. That's written as psi. A wave function is a solution to the wave equation. Number three, the square of the solution to the wave equation is called an orbital. An orbital describes a region in space where you have greater than 90% probability of locating an electron. Now, the first kind of orbitals that we're going to look at are what we call atomic orbitals. And these are s orbital, p, d, f, and g, and so on. S orbitals are spherical, while p orbitals are shaped like dumbbell. And then there are various shapes for d orbitals. For example, this will be one of the examples. Then this is another type of d orbital. There are many others. There are 5 d orbitals. So there is one s orbital. There are 3 p orbitals. So px, py, and pz. And then there are 5 d orbitals. There are 7 f orbitals, and so on. Next, we look at the rules for filling electron orbitals. Number 1 is called Aufbau principle. And this rule says that you start filling the orbitals starting with the lowest energy first. So you start with the lowest energy. Rule number 2 is Pauli exclusion principle. And this says that you start filling the orbitals in opposite spins. So that will be more stable than parallel spins. And then number C, which is the last rule, is called Hans rule. And that says that you start filling the orbitals in parallel spin until it's half full before you start pairing. So for example, that would be 3 electrons. If we have 4 electrons, then you start in parallel, and then the 4th one now you start to pair if this is p orbital. You remember p orbitals as px, py, and pz. So you have px, py, and pz. So if you have 3 electrons, you fill them in parallel spins. After that, you start to pair, where now we see that in the first one, we have paired spins. So one is going up, the other one is going down. And we call that opposite spins. Now putting all these rules together, Aufbau principle says we start with the lowest energy. So 1s is the lowest energy. And then because there's only one s orbital, then you have a maximum of 2 electrons. Each orbital has 2 electrons, so you get 1s2. Then you go to the next level, and that's 2s. S is always the lowest energy, and then a maximum of 2. But at that level 2, you also have 2p, but remember you have px, py, and pz. Each of those has a maximum of 2 electrons, so you get 6 electrons. And then after that, you go to 3s, maximum of 2, and then 3p, maximum of 6. And then instead of going to 3d, 4s is actually lower energy, so you go to 4s2, and then now 3d10. Then after that you continue 4p6, and then continue 5s2, which is lower energy than 4d10, and then you continue 5p6, and so on. Now this information can be used to write what we call electron configuration or electronic configuration, which means you arrange the electrons following this order here. So for example, sodium has 11 electrons. Then you arrange them where you start with 1s2, so that's 2 electrons, you're remaining with 9. Then 2s2, this one here, so that's another 2 electrons, so you're remaining with 7. And then next you go to p, so 2p6. Now we're left with only 1, and that's going to be 3s1. And you stop there. That will be the electronic configuration of sodium. Lithium has 3 electrons, and therefore the electronic configuration will be 1s2. Then we're left with 1. Then the next one now will be 2s1, and you stop there. Carbon has 6 electrons, and therefore the electronic configuration will be 1s2. We're left with 4, 2s2. We're left with 2, 2p2. Oxygen has 8 electrons, and therefore the electronic configuration will be 1s2, 2s2. That's a total of 4. We're left with 4, and that will be 2p4. The other way of writing electronic configuration is to use what we call core structures. And that means we use the inert gas core. For example, helium has 2 electrons. So that's helium on the outer energy level. Helium has 2 electrons. Neon has 10 electrons. Argon has 18 electrons. So we can use that to write electronic configuration. So for example, lithium has 1s2, which is actually a helium core structure. So we write helium because that's 2 electrons and then 2s1. The other example is for sodium. We can use a neon core structure which has 10 electrons. So that one there is neon. So that will be neon core structure and then 3s1. Carbon, we have a helium core structure which is 2 electrons, then 2s2 and 2p2. We use the same method for oxygen. Again, helium core structure for 2 electrons, 2s2, 2p4. Thank you very much for your time.